In this section, we'll install the Squid server, that's the proxy server, and examine its configuration and implement some of its features. This is a requirement for certification within Red Hat's framework, and it's also a widely used proxy server. A proxy server allows you to proxy or filter outbound requests to the internet, and as a result you can take advantage of caching and reduce bandwidth utilization and even limit the websites or the content that your users or constituents have access to. Let's label this section Squid Proxy Server, and the features include caching server, filters access to the net, amongst many other features, including but not limited to efficient bandwidth usage. So as a result of caching requests, for example, if user 1 accesses a website and user 2 attempts to access the same website, if the website exists or lives in Squid's cache, user 2 and subsequent users will have immediate access or cached access from Squid's cache to the site, consequently reducing or obviating the need for the user to connect to the web directly, and that saves you bandwidth. You may filter access to the net, so you may grant or deny access to specific sites, and as a consequence it overall promotes efficient bandwidth usage. Since you're able to cache and filter, users aren't always accessing the net directly. In a standard environment, if we take a look at our drawing for a moment, users access the internet directly without any sort of caching mechanism in place or proxying mechanism in place. But with Squid and similar facilities, users are going to check the cache first, and if the object is present in the cache, the user will not have to visit the internet. So on any of these systems, such as this Red Hat Enterprise 5 system that we're on, if we attempt to access the internet, meaning a site or service on the net that Squid caches, such as FTP or HTTP, we go through our internal environment, the intranet, through the central router to the internet directly to the host server. But when Squid is involved, or a caching proxy server is configured, our system and others will connect to the internet by way of the caching-only instance. We're going to create a caching-only instance on our VMware instance of Red Hat Enterprise Linux, then point our Red Hat Enterprise 5 box to the VMware instance running Squid, which will then provide us with access to the net. And we'll be able to test connectivity and the speed of connectivity once the caching is enabled. So let's return to our notes and continue our discussion of Squid. Our first task is going to be, of course, to install it. So install Squid Proxy Server, and it's relatively straightforward. We'll use yum to do so. If we consult our repository, we'll see the package is simply named Squid, and we'll get that name momentarily once the browser is up. Let's connect to the resource, the server RPM resource. It'll enumerate the contents of the yum repository momentarily, and then provide us access to the items. We'll Control F and search for Squid, and there we see 2.6 being the version that's available. So this is the package we'd like to install. Let's return to the shell. We can install it using its name, its unique portion, of course. And we'll return to the shell on the remote system and execute yum-y install Squid. And this will attempt to install it from the repository using a regular expression match, including any dependencies if necessary. So there we see Squid has been installed. And now when we RPM query list Squid, we'll see all of its components. Scrolling towards the top of the Squid output, we'll see the main components, including its config file, and it's exceeded our screen, so if we dump it to less, we'll see it one page full at a time. So here's the configuration that's currently set up. Beneath HTTPD, confd, there's a Squid entry so that you can access the cache manager via the browser, which gives you a sense for how Squid's performing. There's a log rotate entry, as Squid maintains log files which can easily grow to an unmanageable size. There's a PAM entry which allows for or facilitates authentication. Squid runs as its own service, so there's an initialization.d entry. There's a primary configuration container, etc Squid. So we've installed it. Let's just note yum-y install Squid. And this is the primary configuration container or directory, beneath which we'll find the primary configuration file squid.conf, amongst others, including one for the cache manager, for MIME translations, and others. Squid, in fact, is a proxy server which functions like a web server, like a reverse web server, so it performs similar tasks in translating content access when using HTTP, FTP, and other supported protocols. So it needs to be able to do some of the things that a standard web server can do, such as translate file types or supply clients with appropriate MIME types for a given file type, and various mix and matches. So this is the primary top-level container, but the main config file is a squid.conf file, squid.conf. So this is the primary configuration file. This is the file that you make changes to enable or disable access to the internet or through the Squid Proxy server, as access is disabled by default. There's a default file which you can peruse, compare and contrast against the existing file that's published. There's a startup file beneath etc sysconfig and this or syssh with another session over to this machine, so that we can examine some of the files while we're going through the list. And in this directory we'll find a Squid startup file which includes options that Squid is to honor when starting. There's also a directive that Squid reads upon startup that it uses when it shuts, and that is the amount of time that it's to wait before shutting, which makes sense because you may have active connections flowing through the server when you initiate a shut. When Squid starts, it starts with the option D, which disable, and that's uppercase D, which disables DNS checks. Whenever possible when configuring Apache, Squid, or similar services, disable any sort of name lookup that could impede performance. Beneath user-lib Squid, there's a CGI process, cache manager CGI, which is referenced beneath the Apache configuration directory, which we'll look at after we have the server up and running. It includes various modules for various purposes, such as NT-LAN manager authentication, IP user checks, get password names, and other items. And because Squid is modular, it includes items for authentication to different facilities, like Microsoft's NT or NT-LAN manager or NCSA, as well as YP, WP info, which is WB info, that is, which is a way of getting group information via Perl script. So Squid is modular. It provides a way to plug into various authentication methods. It also includes a client which can be used to test the proxy. This is an important component used to test proxy server, and in particular the Squid Proxy server. Squid client. We'll use that momentarily once we have it up and running. There's documentation, which includes comprehensive documentation in HTML form. There are a list of error files that are referenced if a user attempts to access content the user has no access to. Then Squid will return the errors in various languages, see listed here. And if you scroll through this list A through Z towards the end, then you'll see the remaining GIF files and the primary log directory var log squid. Primary log directory. So out of this large configuration, the things that are important to you when pursuing certification and just for your own intents and purposes is to have a sense of the default container, the default config file, the client which is used to test the server, and where Squid performs its logging. Everything else is above and beyond and can be determined after Squid's up and running. Now, how do we ensure that Squid allows access through in its default configuration? Well, first and foremost, let's ensure that Squid starts and that it's set to start up when the system reboots. So start Squid and ensure that it starts when the system reboots. These are easy tasks. First, we'll service, and again, we'll extract the name from initd. We know it to be Squid, but let's just confirm it. etc initd Squid is the name of the service, which means service Squid start will do the trick, followed by a check config 3.5 for run levels 3 and 5 Squid on. We'll ensure that Squid starts when the system is rebooted or switches run levels. So, with that said, let's service Squid status first to see whether or not it's running. It should not be. And then we'll service Squid start. This starts the Squid caching server. It sets up its cache beneath var spool Squid. And one thing we should note regarding Squid or any proxy server is that you are to be sure that you have ample disk storage in the spool directory. Squid expects enough disk storage, especially in busy environments. So ensure that ample disk storage. We should also note not only ample but fast disk storage is available for var spool Squid, as Squid caches the contents of web pages visited by users beneath the structure var spool Squid. So indeed it is an important location. And we'll just note cache directory container. So as users request content off the net, Squid caches that content beneath var spool Squid. So it'd be prudent for you to run df-h to see how your var partition is set up. In our case, our var partition has 1.8 gigs, but for our intents and purposes, this is more than enough space. Ideally, in your setting, place your var mount point or mount var spool Squid specifically on a fast volume, such as one configured using LVM or perhaps RAID level 0, etc. And as we've just recently done, the server is started. We can confirm the steps using netstat ntlp grep Squid. You'll see that it binds once we get the netstat command properly run to port 3128. So by default, Squid binds to port 3128. Note Squid defaults to TCP 3128. This becomes important when you configure your client, your web browser client, whether it be a text-based browser or a graphical browser. A text-based browser also includes wget. Many programs make use of proxy services, and in the case of Squid, be prepared to reference port 3128, although Squid can be certainly configured to listen to any port not currently in use by some other process on your machine. So this is Squid running on port 3128, and it's listening to all IP version 4 addresses, which means it's ready to accept connections. So our next task before we enable traffic to flow is to configure browser. We'll configure Firefox browser to use Squid Proxy server. And that's a straightforward process. In Firefox, we'll simply navigate to where our options or preferences are located. Within Linux, it's Edit Preferences. Within Windows, it's Tools, Options. Both lead to the same general area. And once in that general area, we'll make the change to point to our proxy servers. There's a connection area, and you'll see a manual proxy configuration area. So after you've located in the General tab, determine how Firefox connects to the Internet, in the connection area, change from direct connection, which is the current layout, to manual proxy configuration. And once you've changed to manual proxy configuration, indicate the name or IP address of the proxy server. Let's start with the IP address, which is 192.168.75.199. The port isn't 0, of course, it's 3128. You may optionally use this proxy server for all protocols listed below. Squid supports proxying for the protocols listed. We'll click on OK, close, and now subsequent sessions, that is, out to the net, will make use of the proxy server. Now let's try to refresh access to 75100 to the server repository, and notice Squid is picked up, indicating that it could not retrieve the URL. Access is denied. This is the default configuration, and on the exam, if you do pursue certification, this will be the default installation, whether you install Squid or it's pre-installed for you. So your first task will be to allow general access out to the net from your local subnet. Our local subnet, if you recall, is listed above as 192.168.75.0/24. We want to indicate this subnet in the default Squid configuration file, and we do so using an ACL or access control list entry. Squid supports many such access control entries. So the fourth task is finally to configure Squid to allow LAN access through to resources for which Squid can serve. So to do so, we're going to modify, let's list as step A, nano etc squid.conf. This is the main config file which houses the ACLs. They can be split off, but this is where you'll find them by default. So let's navigate to that directory, then nano squid.conf. And in here we want to manipulate our ACL section. You can go ahead and do a search using Control W if you're following along in search of ACL, and you'll see different references to ACLs. But as you navigate throughout the directory, you begin to see uncommented ACL definitions. Items that begin with hash marks are commented items, whereas items that do not begin with hash marks are non-commented items. So we can include an ACL setting anywhere in the document. Just be sure that there are no deny settings currently defined. And there's in particular an access control section. Let's go ahead and Control W. Beneath the access control section, you'll find everything you need to know regarding how to define ACLs based on criteria supported by Squid. We should just note as well in its feature set that it supports a wide criteria of ACLs. For example, based on destination domain, source IP, time of day, etc. So you can build ACLs based on a wide criteria, tailoring your environment to suit your needs. So in this access control section, if we scroll down, you'll see where HTTP access is denied by default. You'll also see that it's heavily commented. You can block based on MAC addresses or allow based on MAC addresses, day of the week, the port that's being accessed, the site, the source, you name it. We cover a lot of these features in Linux CBT Proxy Edition featuring Squid. But for our intents and purposes here, in this edition of Linux CBT, we're going to enable LAN access. Now here are some rules that are uncommented, meaning they matter. This ACL all, source, all IP addresses, all subnet masks is later reference for HTTP access. So let's scroll down, and we see some safe ports that are defined. These are ports that can be serviced through Squid. Squid knows how to handle traffic to those ports, including your SSL, web, FTP, etc. But if we keep scrolling down, we'll see where the reference is made to deny all access by default. The default is HTTP access deny all, but this is not where it gets done. This is simply a commented area. Below, if we scroll down, we'll see that HTTP access is denied to all users which is referenced by the ACL defined above, HTTP access all, or all ACLs. So here, HTTP access, meaning if you're accessing SSL or HTTP based sites, you'll be denied access. You can change this to allow using HTTP access allow all, and this would match all IP addresses on all subnets that go through this proxy server. There is an allow, however, if localhost access is attempted. Let's see what localhost means. If we scroll up, we'll see where the ACL is defined for localhost. We can do so using Control-Y to go up or Control-V to go down. But since we're already moving up with the arrow key, we'll just find where localhost gets defined. Here we see that localhost is defined to mean all source, or the source IP address in this case, 01, all 255s. And below, we see that localhost is permitted access through the proxy server. So if you are connecting through your proxy server to a local web resource, Squid will not prevent you from connecting. However, if you are connecting through the proxy server using a routable address, you'll be denied because you'll be lumped into the group all. Also notice that the rule allowed comes before deny. So if you are connecting from localhost, you'll be allowed, but if you do not match localhost, you'll be trapped by this rule. So to permit access for our local subnet, we'll indicate HTTP access, and let's just include that this is to permit access through proxy server by members of our local subnet 750/24. And this is our rule, which we can reference at some other point. So HTTP access allow, and we should define the group perhaps as local net or local subnet or internal net or some useful name. We're going to define it right here as the following: ACL LAN users, this will be our name, with any source 192, and this is a type supported by Squid, source that is, destination is another type, DST, 168.75.0/24. So this is a definition of a source block. We'll allow access via that source block. So we'll allow it using the name LAN users. This will permit access. Otherwise, access will be denied through the Squid Proxy server. We'll go ahead and save the changes. We'll need to restart Squid. And barring no configuration errors, Squid will restart and be back up and running momentarily. Let's try to access an external resource again, or let's begin with an internal resource, the repository at 100, and there you see it comes up. There's really no indication that Squid has served this information. It's all apparently transparently done, but it's quick, and as a consequence we don't see the traces. So basically, locally, we are logged onto this system, and we are using the VMware instance of Red Hat Enterprise running on this remote system to connect to resources, or in this case, a resource on this system. So we're going from this box to this box to get to this box. Now we'll go from this box to this box to get to a web box. Let's try to hit, let's say, our website through the proxy. And this is being proxy served. We can confirm that this is being proxy served by examining the contents of the logs. We did mention that the logs are stored beneath var log squid. So if we take a look, we'll see that there are multiple files. Whenever you access a website or a resource that Squid's able to serve, Squid stores that information in access.log, similar to the way Apache stores access through its access log. So if we tail access log, we'll see requests that are made from internal hosts through the proxy server. By virtue of connecting to linuxcbt.com, we see the hits or misses. The misses, that is, are non-cache hits, meaning if you see a TCP miss, that means the item wasn't in the cache. So Squid had to connect to the server to connect to the public server, that is, or to the actual target server, destination server, to get the file of interest. And whenever you see a hit, that means it was in the cache. But in any event, the local client browser used, in all cases, the proxy server, we see the source being .10, to get to the target, linuxcbt.com, various items including Google Analytics, images, JavaScript to load the menus, you name it. We are going through the proxy server. And there are various files like the store.log, which reveals items that are in the store. By the store we mean in the Squid cache. And there's timing information and errors related to those items in the cache. 200 errors or 200 related messages are usually good, meaning they're in the cache. 300 usually mean, or 300 or 30x usually means redirect related items, and those are usually not in the cache and need to be loaded each and every time. So the files that are here, access log, cache log, store.log, maintain useful information. Squid.out tells you the last time Squid started, the fact that it created the directories that it uses to conduct its business. Again, for a deeper analysis of Squid, look at LinuxCBT Proxy Edition. The version of Squid studied in that edition of LinuxCBT may be 0.1 off, but basically, by and large, over 99% of the directives are identical. Just perhaps bug fixes or slight differences between the version examined there and here. So Squid really hasn't changed in well over a decade significantly. So with that said, we are connecting through the proxy server, and there are different ways to enable or disable rules. For example, if we had a host on the DMZ that we attempted to connect through the proxy as, it would currently fail because of the way we've written the LAN users rule. So if we wanted all users to be able to connect through the proxy, we would adjust the rule by grouping multiple subnets. Instead of simply 192.168.75.10, we could make it 192.168.75.10 space the other subnet, and that would allow us to connect through. Let's just indicate the rules that we've written, or the rule that we've written, which is ACL LAN underscore users. That's the name of our rule, which is assigned the type source, which accepts source IPv4 addresses, such as 192.168.75.0/24. And then we follow that up with HTTP access, which is a keyword used by Squid to mean provide or deny HTTP access, depending on what follows. We indicated to allow access to LAN users, the grouping, and then it's followed by a deny for all other users. We could also allow one user and deny another user. It's quite a possible way to implement Squid. For example, let's deny our local system but permit everyone else on the subnet. So fifth task would be to deny 192.168.75.10 but allow all other users from the local subnet. So we'll need a rule set which resembles the following. ACL LAN, let's call it bad users, source 192.168.75.10 would indicate the distinct host. We could optionally follow that up with a 32-bit mask or just leave it be. And then we also need to indicate, and let's just include this on one or in one block so we can easily copy and paste it. So this would deny the user. We need a rule which resembles the following: HTTP access, deny ACL LAN bad users. We need to ensure that these two entries come before the allow for the subnet. And this will match on .10, deny .10, but permit other users. Let's return to the Squid directory beneath etc. We'll nano squid.conf, and we'll find ACL LAN, which is what we currently have in place, and that's LAN underscore, that is ACL space LAN underscore. So right before, let's indicate that we'd like to deny. So to deny specific hosts, because again, like a firewall, Squid processes these items on a first-come, first-served basis. So what it sees is what it processes first, and the first match is what will be allowed. Let's navigate again to LAN user and paste our item using Control-Shift-V. So this will deny .10 and then permit every other host. And we can test any other host, doesn't need to be a graphical host, by simply using a shell-based interface to a remote system and setting an environmental variable. We'll save the changes, then execute service, and we'll just exclamation service because it's in our history. Now this threw an error. Let's just double check our rule set here. Make sure that our rule set looks right. And in fact, HTTP access deny ACL LAN bad users, that looks fine. And we've inadvertently placed an underscore between ACL and LAN. We could name the ACL with a prefix of ACL, but then we still need a prefix command of ACL. Let's try it again. And that's more like it. We'll PSEF grep squid, and it's up and running with the upper D option. So as .10, let's try to use the Squid server. It should deny us. We'll try to refresh linuxcbt.com. Squid throws an error. Let's try to hit some other sites like Google. Another error. Let's try to hit our RPM repository. Ditto, another error. However, if we connect to another system on our internal network, let's Control-Shift-T. SSH is root over to linuxcbt media 1. We'll connect using IPv6, the 6-to-4 address. That's what was ascertained from DNS. And once on this remote system, we know it has wget installed, and wget supports proxies. By the way, any program which supports proxies, such as FTP or HTTP-based programs, can be set to use Squid, because Squid supports those protocols. In the case of wget, you need to export a variable. It's called http_proxy. If we set grep http, what's returned includes variables, or one big variable which contains the HTTP but not the http_proxy variable. So then we'll export http proxy equals setting it to the IP address of the proxy server, followed by the port 3128. Then we'll follow that up with a set grep htt_, and there we see it set. So now when wget executes, it will use this variable to determine which proxy server to use. Now we need a document. We need to try to access a document, and that will cause Squid to fetch a document for us. So let's wget http www.linuxcbt.com index.php. This is the default page. Now we see we've got index.php, which represents the linuxcbt website. But don't trust the document we've downloaded. Consult the proxy server. So let's navigate to var log squid, and we can tail access log, where we'll see the .100 box TCP missed getting www.linuxcbt.com index.php. We can try it again. The byte size is included as well for each request. And we should see a second entry. It was again a TCP miss. For items that are cached, the subsequent downloads will be much, much faster, returned to the client much, much quicker than for items that are missed. Otherwise, roughly the same transfer rate, because the client was forced to visit the net, would be returned. Again, be prepared to have a lot of disk storage, but by connecting using that HTTP proxy variable using wget, we've proven that you can allow a set of users from your subnet and deny one or more users from the same subnet. Now, we did mention earlier that there is a client named Squid Client. Which Squid Client tells us that it's in a place accessible to root. This client can be used to test your proxy server. Using Squid client with no options returns the possible options, and sensible options include G, which allows you to send a certain number of requests to the target server or document. So we'll Squid client G 3 times http www.linuxcbt.com. This will fetch your default page 3 times, returning statistical information regarding the transfer rate of the document. This is a great way to test whether or not your proxy server is caching content. In the case of this document, it appears that it's not, because each return comes back in roughly the same number of milliseconds. And in each case we see it's just under 450 thousandths of a second. So let's try to get another set of content from the default repository 75100 RH5, and let's just get the full URL and copy and paste it instead of memorizing it. This will attempt to get the default page 3 times using the proxy server's help. And as you can see, the millisecond response roughly the same each and every time. But you use the client again to test getting or gaining access to content. You can use it to authenticate using HTTP authentication. You can also indicate a specific port, a specific host to retrieve a URL, and other items. Now, one last point regarding Squid configuration, and that is you can alter the port. You can change the default port if 3128 does not suit your needs. Search for 3128 in the main documentation, and you'll see the uncommented directive http_port. This directive, if switched to, let's say, 8080, which is commonly found, will allow your users access using 8080, regardless of client type. And let's also find LAN users. Because we want our local system to be able to gain access, we'll turn off the rule for .10. We don't want to deny .10, so we'll just comment it all together, which will cause Squid to match .10 to this rule, allowing access. So we'll save changes, service Squid reload, and once Squid has reloaded, let's just echo $. We'll try to access content again, and this will check against the rule set. And usually if it takes this long, it means it works. So you can reload the server to avoid having to restart it altogether, which would kill existing connections. So again, just to recap, Squid is a proxy server. It's a caching server. It caches content, HTTP, FTP, HTTPS content, and it supports a wide criteria of ACLs, a really large criteria. Just consult the documentation. Also look at Linux CBT Proxy Edition featuring Squid. It is highly customizable, used in many production environments, and can make your bandwidth utilization come down, and it's very stable.